Okay, so I want to go over just a handful of the questions. If anyone had any problems, from the assignment, I'm going to look at number 13, 19, 37, 39, 47, and 51. So if you had a lot of problems, hopefully looking at one or two of these will help you understand a little bit better. If you only had one or two problems, again, hopefully this will help. If you got all these right and you had a question about a different one, we'll talk about it next week or next time we're in class. But in general, if you were able to handle all these problems just fine, then you should have a pretty good understanding of this material. Okay, so let's first look at number 13. This was on page 267. So number 13 is just dealing with opposites. So I have 3 over x minus 5. And I'm adding to that 2 over 5 minus x. Again, when I deal with opposites, I'm going to, in a sense, kind of pull out or extract the negative from one of them. So my problem becomes 3 over x minus 5 plus 2 over negative x minus 5. If that's confusing, think about this. 7 is related to negative 7 with an opposite. If I take the opposite of the opposite, I get the original number. So the opposite of negative 7 is positive 7. Here, the opposite of the opposite is my original. Okay? But now these are the same except for this negative, but recall from before, I can move the negative up to the top. So I get 3 over x minus 5 plus negative 2 over x minus 5. My denominators are now the same, so I get 3 minus 2 over x minus 5, which is just 1 over x minus 5. All right, so that's 13. Let's look at 19. Number 19. 1 over 2x squared minus 5 over 4x. So here we're actually required to do a little bit more work in terms of finding the factors here. All right, so if I want to think about my denominator here, this is kind of like 2 times x times x, and this is 2 times 2 times x. If I want to think about maybe finding a way to find the prime factorization. So my new denominator needs to have 2 2's in it and 2 x's. All right, this denominator has 1, 2, and 2 x's. So to change it to here, I need an additional 2, so I need to multiply the numerator by 2. So my 1 times 2 is simply 2. Over here, my second fraction, my denominator has a pair of 2's and an x. Here's the pair of 2's and 1 x. I need another x. So to change this denominator to my new denominator, I need to multiply by x. So I multiply the numerator by x, 5x. So my new fraction becomes 2 minus 5x over 2 times 2 is 4, x times x is x squared. I can't do anything else because I can't cancel these x's because of the subtraction here. That's the answer. All right, number 37. All right, so I have 2 over x minus 3 plus 4 over x plus 3. Now be careful. We might be tempted to say, oh, well, the factors down here are x and negative 3, and here they're x and positive 3. But that's not right. This number down here is not x and negative 3. It is simply one number. Okay? There's no multiplication here. So this whole thing has to just be x minus 3. So the factors of the first one are this. The factors of the second one are this. These numbers do not have anything in common. Okay? They're relatively prime. So therefore, my new denominator is going to be x minus 3 times x plus 3. All right, so if I'm going to change this fraction to have a new denominator, I already have the x minus 3. I need to multiply by the x plus 3. So this is 2 times x plus 3. I'm adding my second fraction. So I already have an x plus 3. I need the x minus 3. So this is 4 times x minus 3. Again, I can't cancel stuff because there's that addition in the middle. So what I can do is actually use the distributive property to multiply. 2x plus 6 plus 4x minus 12. 2x and 4x is 6x. 6 and minus 12 is a minus 6. Okay? If you wanted to, if you felt the need to, you could factor out a 6 here, but that's only helpful really if it allows us to eliminate something in the denominator, and it doesn't. So this would be the final answer for number 37. Number 39. Okay, again, notice these denominators. We're tempted to think, oh, it's just one more, but think about, this is 17 and this is 18. These numbers are relatively prime, so my new denominator is going to be a times a plus 1. All right, to change this first fraction into this denominator, I already have the a. I need to multiply by the a plus 1, so this becomes a plus 1 times a plus 1. There's my subtraction. Here, I already have the a plus 1. What I need to do is multiply by the a, so it's a times a. All right, now to finish, here I need to do FOIL. A squared plus 2a plus 1 minus a squared over a times a plus 1. I have an a squared minus an a squared, so in the numerator those cancel, so I'm left with 2a plus 1 over a times a plus 1. That's our final answer. All right, 2 more to go, 47. Okay, so I have a over ab minus b squared plus b over ab minus a squared. All right, so now when I look at these, I might see that, hopefully I do see, that there is a common factor here, okay? So I can do a little factoring and then find my least common denominator. If I factor this first one, I can factor monomial factor b, so this becomes b times a minus b. Both have a b term. Over here, I have a common factor of a, so this is a times b minus a. All right, now there's a little bit of a relationship here. These are opposites, okay? So my common, to find that least common denominator, I might want to think about making this negative a times a minus b. All right, think about that again. The opposite of this is minus a minus b. These are equivalent. So I take that negative and put it on the a, and now I have that kind of AB term that's the same. So it makes my denominator, I've got a negative a, I've got a b, and I've got an a minus b, which is all the terms there. So I have the common a minus b. I've got a b and a minus a. Okay, so now to get there. This first term right here has the b, has the a minus b, but I need a negative a. So I multiply the numerator by that negative a to get negative a squared. All right, my second term over here, plus. I have a negative ab. I need that b plus a b squared. All right, take a minute, do this, make sure you're on top.